In this video, we look at an exam-style question about friction on a slanted surface. The question also asks about acceleration, and I especially want to point out some common mistakes. So let's read the question. Calculate the acceleration of a skier heading down a 30-degree slope, assuming the coefficient of kinetic friction or for waxed wood on wet snow is 0.2. The common biggest mistake is that when people see the question asks for acceleration, so they would write down what they know about acceleration, so force equals ma. And because it's a friction question on a slanted surface, they would also write down the friction calculation, so F max equals mu, so friction coefficient times normal force. And if you remembered well, you will know that the normal force here, instead of gravity, mg, it's going to be gravity times the cosine of the angle. So that seems like everything is given, and the biggest mistake people make is like look at the two formulas and say, look, force equals force. So ma equals mu mg cosine 30 degrees. And they put, and then they notice, okay, you can cancel the mass, and therefore I have acceleration equal to this number. And this is absolutely wrong. Okay, the reason, you are equating the force that is leading to acceleration, so the force that is making acceleration happen, to the maximum friction force, or just simply to the friction force. Even if that's not the maximum force, that's still friction force. Okay, so how can friction make objects move? Friction is the force that stops things moving. It cannot lead to acceleration. So you have to notice that your force in the acceleration formula is the resultant force. And the resultant force is the net effect of all forces. In a sliding down the surface scenario, if you have a box, there are only three forces, actual forces. There's your gravity, there's the normal force, the force that the surface is supporting the box. And then when it's sliding downward, friction, force of friction is trying to stop it slide downward. So what's the resultant force then? The resultant force, you have to now then decompose the gravity into the two parts. That's where our mg cos and mg sine comes into play. So the mg cos is this blue arrow here, which is the opposing force of the normal force. That's why our normal force equals mg cos. So let's just cross out this section and then look at what we should write. So on the y direction, your normal force and your sort of the blue arrow, the gravity, mg cosine theta, they are balanced because the box is not flying off the surface, not sinking into the surface. That's where we can get our normal force from. Really, the motion occurs only along the surface, so that's in the x direction, where you have a resultant force. So resultant force, if this object is moving, we want to find out the acceleration of the movement. That must mean the downward direction. So let's do this in green. So this green arrow, this direction, is going to be more than what's stopping it. So let me call that the sliding force. Okay, the sliding force minus the frictional force, that equals ma. Okay, sliding force, it again is in this gravity decomposition right angle triangle. If the blue one is cosine, the green one is the other one is sine. So the sliding force basically is mg sine theta and minus my friction force. So the friction force calculation, the formula up here itself is actually correct. So we will plug that in. So coefficient of friction times mg cosine of theta equals ma. That is the correct way of using the Newton's law about acceleration. Ma equals the resultant force, not any force, not friction force especially. Okay, now at this point you will notice that the mass is in every single term of the equation, and that's where you can cross it out. And also that's a good point to point out for a question like this, and you think all the formulas would require a mass, but the question didn't give you a mass. And that's kind of a hint saying that, in fact, as you start solving it, you will notice you do not need the mass number to solve this question. Okay, now we should have every single information. I can just plug all the numbers into the equation, and I should get my acceleration A. So G is the gravitational acceleration, G force, 9.8, times sine of 30 degrees, minus mu here is 0.2, again times 9.8 G, and times cosine of 30 degrees. And that number, if you put it in the calculator, it should give you the acceleration. And that equals 3.2. And don't forget the acceleration units, meters per second squared. All right, to sum up, the main thing that you need to absolutely be certain is your acceleration formula is resultant force equals mass times acceleration. And for the resultant force, it's the net effect of two opposing forces, the sliding force and the friction force. On a slanted surface, sliding force is mg sine theta, and friction force is mu times the other side of the right angle triangle, so mg times cosine theta. Has the extra mu because it's a friction coefficient in the front. Okay, so that's the end of solving this question. Right, thank you for watching.